Hello students, today we are going to take up the topic hybridization and geometry of a molecule or an ion. This is very important topic of inorganic chemistry, basic fundamentals. Let us start. Thought for the session is success is not final, failure is not fatal. So we should try again and again to get success. Learning outcomes from this session is the hybridization of a molecule or an ion to find the lone pair in a molecule, geometry of the molecule or an ion. Hybridization spelling we need to correct. So what is I am not going into what is hybridization. I am dealing here now that how to calculate quickly the hybridization. Let us start. We have to calculate Z. What is Z here? Z is number of atomic orbitals, which will give us the information for finding the hybridization. If Z value is 2, hybridization is sp. If 3, sp2, 4, sp3, 5, sp3d, and 6, sp3d2, 7, sp3d3. Now here how to calculate Z? That is the next point. So Z is calculated with the formula Z is equal to 1 by 2 of number of electrons in the valence shell. Whenever I am talking of number of electrons in the valence shell means I am talking of central atom plus number of monovalent atoms. Monovalent atom means which are having valency 1 plus charge on anion minus charge on cation. If it is a cation, we have to reduce the charge, and if it is an anion, then we have to add the charge. So we will understand more with the example. Let us start. So these are certain examples I have given. So Z, if it is true, the hybridization will be sp, linear, and examples have been given. Similarly, sp2 trigonal planar, sp3 tetrahedral, and sp3d trigonal bipyramidal, octahedral, pentagonal bipyramidal, and the angles. Now, one thing we need to understand is these geometry, structure, shapes we have to keep in mind because these are 3D structures. We should understand that what is trigonal bipyramidal, what is octahedral, what is pentagonal bipyramidal. Not simply we can draw. We have to visualize this thing because spatial understanding is required to understand this particular shapes and structures of any molecule. Okay, let us see if the molecule is not having any lone pair, the shapes would be regular. But if the molecule is having some lone pair, that the shape will be distorted. It may change into, for example, tetrahedral is the arrangement. It may not be tetrahedral, it may be pyramidal. So this type of things will come into play. So let us, before doing some calculations for the hybridization, I would like to tell you that the valence electron, how to remember, how to see. See, in a group, valence electron remains same always. So if you are talking of group 1 alkali metals, so valence electron is always 1. So no need to remember for we have to calculate and all that. Nothing is required. If you know that element belongs to group 1, it means 1. If element belongs to group 2, it means 2. Similarly, 13, 14, 15, 16, 17, 18. 13 means 3, 14 means 4, 15 means 5, 16 means 6, 17 means 7, 18 means 8. So if you want to calculate for xenon compounds, so you have to take 8 valence electron. Okay. Now let us do the practice. So practice, please do it listen it very carefully and try to do as much as practice you can do for the molecules. PCl 5. Now our formula was Z is equal to half number of valence electron plus number of monovalent atoms plus charge on anion minus charge on cation. Now here there is no cation, no anion, so 0, 0. Valence electron for central atom phosphorus is 5 because this belongs to group 15 elements. Nitrogen, phosphorus, arsenic, antimony, bismuth. So please focus on this thing what I am telling you. If you are able to keep in mind this, so all the hybridization you can find it very easily. Now 5. Now how many molar atoms? Because chlorine is having valency 1. So how many? 5. So 5 plus 5, 10, 10 divided by 2, 5. So Z is 5 means sp3 hybridization. Now there is no lone pair here. So therefore geometry is trigonal bipyramidal. And angles, if you want to know, 3 angles would be of 120 degree and 2 angle of 90 degree, one above, one below. And the plane triangle is there in the plane. Okay, so you can try similar type of example. The hybridization may not be same, but the type is similar. There is only monovalent atoms attached. Okay, now if type 2, central atom is surrounded by divalent. Divalent means valence is 2. So now carbon dioxide we want to find out the hybridization. So formula remains same. Please see Z is equal to half. Carbon belongs to group 14. Valence electron 4. Plus there we have written 0. Why? Because I am not bothered about the divalent. I have to bother for the monovalent. So 0 is there. Divalent 0. So we will not write here. Monovalent is not there. So 0. Divalent we are not bothered. Similarly, Z is equal to 2 will come here. So here also there is no lone pair, therefore regular geometry is there. Okay. So similarly you can try for the SO2, SO3. This is a similar type. Hybridization may be different. Next type number 3. Central atom surrounded by mono and divalent atoms. Mono is also there and divalent is also there. But we have to take only monovalents. So let us Z is equal to half bracket 4 plus 2 because 2 monovalent are there. Divalent we have not taken. 0 and 0 because there is no charge, cation, no anion. Okay. So total is 6 by 2, 3. So 3 means sp2. So there also no lone pair. Therefore geometry is triangular planar. 120 degree angle. And because why, how this angle is calculated? Total 360 is there. 360 divided by 3, 120. This is the way to how to calculate. You can practice further for XCO2, F2, POCl3. So you will be asking, sir, how to find whether we have to check whether answer is right or not. So you can just type on the Google that what is the hybridization of POCl3. You will verify that something you have to do to get something. Okay. Next is anions, sulfate. So sulfate, this is the type for anion. Now we are done doing anion type. Anion means charge is there. Z is equal to half. Valence electron, sulfur belongs to group 16, so 6 valence electron plus no monovalent plus charge on anion is there. What is the charge? 2. You need not to add minus 2. Charge only you have to add, nothing else, magnitude of the charge. And the cation is not there, so 8 divided by 2, 4. 4 means sp3 and there is no lone pair, hence we can say geometry tetrahedral. Similarly, you can try for the other anions like carbonate, phosphate, nitrate, nitrite. Next is type 5, that are cations. Ammonium, Z is equal to half, valence electron, group 15, nitrogen belongs to group 15, 5 valence electron, monovalent 4, plus no anion, and this cation is there, so minus charge. So total is 8 by 2, 4. 4 means sp3, and no lone pair. So the geometry is tetrahedral. Similarly, we can calculate for hydronium ion also. Now the next type 6 is complex. So complex ion. So how we can calculate is same manner. I belongs to group 17. 7 valence electron. Half 7 plus 4 monovalent. Charge on anion 1. Cation is not there. So total 12 by 2, 6. So here also 2 lone pairs are there. So students will be asking a very important question that how we are coming to know about the lone pairs. So please wait. In the next few slides I will tell you how to calculate the lone pairs. Okay. Next is it is an irregular geometry, not regular. Irregular geometry, distorted octahedral. Okay. Now similarly, hybridization of complex compounds. Coordination complex. So this is under chapter 9, coordination compounds it is coming. And so far we can do little, but more detailed way we will do in the chapter number 9 also. Okay. So here ligands are there, central metal atom is there. For example, CONH3. CO is a central metal atom, that is always a transition element, and ammonia is a ligand. Ligand is always a lone pair donor. So it is forming coordinate bond between ammonia and cobalt. Okay. So square bracket, we are representing any complex compound in square bracket. It can be charged, it can be neutral, it can be negative charge also. Okay. The charge on the complex. Now here we need not to calculate about this valence electron and all that. We have to calculate what is the ligand, how many ligands are there. How many ligand means how much is the coordination number. So the ligand is total here 6. If 6 ligands are there, the hybridization is sp3d2. So this way we have to calculate, and more detail we will discuss in the chapter number 9, coordination compounds. Okay. Next. So we were telling you how to calculate lone pair. See how to calculate lone pair is, now we have calculated Z. Z means number of orbitals used in the hybridization, and Z minus the number of surrounding atoms. If you do, then will be given us the lone pairs. So calculate the hybridization and lone pair. Let us say this question is there. Z is equal to 1 by 2, 5 plus 3, 8 and total Z is 4. 4 minus what are the numbers of number of atoms attached in the near the phosphorus? 3. 4 minus 3, 1. So 1 lone pair. So 1 lone pair means this shape should be tetrahedral, but actually from regular geometry to irregular shape it changes to pyramidal. So this is the point to understand here. Next, one more example we can take for this particular lone pair and hybridization. Let us take the case of SO2. SO2 hybridization 1 by 2, 6. Monovalent is not there and no cation, no anion. And 3 means sp2. sp2 means 3 minus 2 atoms of oxygen. So 1 lone pair is there. 1 lone pair means the shape will be bent like water. Okay. Similarly, calculate the hybridization lone pair of SO3. So in case of SO3, Z is equal to 1 by 2, 6, same, sp2 and no lone pair. Why? Because 3 atoms are already attached, 3 oxygens are attached. So shape is regular, triangular, planar. Okay, so now moving forward, so these are the shapes. If regular geometry is there, linear shape, these are the examples. I should say that you should full-fledged check all the compounds with the particular hybridization, then your grip on the hybridization will be moved. Similarly, sp2 trigonal planar 120 degree angle, so 360 divided by 3, so 120. This is the manner. And sp3 tetrahedral arrangement is there 109.5 degree. This is the regular. I am talking of regular, no lone pairs. If lone pairs are there, shape will be changes into some pyramidal, it will be bent. So all these changes will take place. And if you are talking of sp3d triangle bipyramidal, and where the 3 angles are 120 degree in the plane and 90 degree above and 90 degree below. Okay, PCL5, PCL, PF5, and next is sp3d2 or d2sp3. So now d2sp3 also ligands. How many ligands are attached? 6 ligands. So please see here, 6 ligands are there. So in the square bracket complexes. Okay, so this way we are doing that all angles are 90 degree. 490 in the one plane, 90 degree above, 90 degree below. So okay, 6. But here also no lone pairs are there. So sp3 d3 pentagonal bipyramidal. So 360 divided by 5. It will be 72 degree. This way angles are calculating. We are calculating the angles. 5 in one plane, 1 above, 1 below. 7 total angles. 7 bonds, sorry. And the dsp2 and square planar. Here I have done it. Here coordination number is 4. Okay. So if coordination number is 4, dsp2, mostly these two hybridations you will find in the complex compound. sp3, dsp2, sp3d2 or d2sp3. These are the 4 main hybridization normally occurring in the coordination compounds. We will do again in the chapter number 7, no need to worry. So let us do practice for this question. If you are able to do, I will say that you have understood the concept. Hybridization of XCFO, try to do that. So you can pause the video and I will proceed further for the answer. So xenon, number of valence electron 8, 1 by 2 8, monovalent 4, 12, 12 by 2 6, sp3d2, and lone